Oh, hey there! Welcome to my channel. Today we're going to be building a dynamic range compressor using a series of IC chips and a multiplier. Stick around!
But what does that mean?
A dynamic range compressor normalizes volume, which means extra loud sounds become not as loud and quiet sounds become louder. This is done by choosing a threshold above which all sound will be, or all amplitude will be affected by a ratio determined by the ratio between signal processed and set back into the input and that input signal itself. That compression happens here in the multiplier. The filtering happens over here. What's this thing called?
Oh, isn't that an amplitude detector?
You're right, an amplitude detector. From the amplitude detector, it then sends a DC signal, which is an integer of the processed input signal. And it sends it into this summer, which allows us to then control how much, using this pot, of this signal is being sent back into the input over here. Here, there we are. This op-amp then, with its resistors and capacitors, determines a ratio of how much the input or the fed back symbol affects the new signal according to this pot right here. This will act as a sort of volume control. But in order to adjust gain in the larger sense, we can use this pot over here, which connects to a second op-amp here. This allows us to amplify the signal much larger than its original value.
When can this be used?
Great question. Let's ask Max.
Well, as a filmmaker, I can tell you for sure that if I want to record a quiet sound followed by a loud sound, I sure as hell can't just use no software at all. I need to use something that changes the dynamic range between the highest points in my sound and the lowest points. That's right. And guess what can help me with that? Dynamic range compressor. I can set thresholds so that upon reaching them, the sound can be adjusted to what I want it to sound like and the optimal volume for me.
Hey Eva, what circuit did we use?
Great question, Luke. Well, this is the schematic we were going off of at the beginning. This chip, the AD633JN, is what we used right here. This is the automatic gain control circuit and multiplier. The op-amps that you see here, well, we had to use the IC chips that contain multiple op-amps each to create to get to these op-amps.
Wow, that sure looks neat.
Yes, it would be great if it still existed. Sadly, this chip is obsolete. It was discontinued back in 2008. Wow, what a weird thing. How could we fix that, you ask? Great question.
I did ask that.
Well, you don't. You just replace it with other complicated things. Like this. Oh. Like this, what you see on the breadboard. This part, all of this half, is a replacement for this one chip. Wow, that's a lot of work, huh?
Can I see the schematics for those replacements?
Yes, of course. Here's one of them. This is what we see right here. Again, we had to use this IC to get the op-amps. And this is the summer that Luke talked about earlier. The other part we had to replace is right here. This is a very simple circuit, and it is an amplitude detector. It only uses a diode, a resistor, and a capacitor. But be careful with this part, you have to do some math. You have to calculate, and the formula goes that 1 over 2 pi RC has to be smaller than the lowest frequency people can hear if you want to encompass all of the wonderful sounds humans can hear.
Wow, that sounds really great.
I know, I love science.
Wow, that sure was fun.